The mechanism of action of Reblozyl, luspatercept-aamt, an erythroid maturation agent. Erythropoiesis is the normal process of red blood cell development. Ineffective erythropoiesis, however, is an underlying cause of anemia in certain cancers and hematologic disorders. In order to better understand ineffective erythropoiesis, let's first discuss how erythropoiesis typically works. Erythropoiesis is a dynamic differentiation pathway that starts with the proliferation of erythroid precursors in the bone marrow and ends with the maturation of enucleated red blood cells. Here, we see one cell going through the process of erythropoiesis, starting from early-stage proliferation through late-stage maturation. Proliferation is characterized by early development of hematopoietic stem cells to erythroid-committed progenitor cells. These cells continue along the erythropoiesis pathway to differentiate or become more specialized. Enucleation occurs during the final stages of maturation. This maturation is characterized by differentiation of erythroid precursors to functional red blood cells. Erythropoiesis is regulated by transcription factors and cytokines, whose roles vary throughout the process. One of the major cytokines involved in early-stage erythropoiesis is endogenous erythropoietin, or EPO. EPO regulates proliferation through stimulation of erythrocyte precursors. While EPO is required for proliferation of erythroid progenitors, cells become less dependent on EPO as they differentiate and erythropoiesis progresses. In late-stage erythropoiesis, select transforming growth factor beta, or TGF-beta, superfamily ligands play an important role in regulating maturation. Under normal circumstances, erythropoiesis results in the production of mature red blood cells. Compared with steady-state erythropoiesis, ineffective erythropoiesis is characterized by three factors: increased proliferation and abnormal differentiation of erythroid progenitors, increased death of erythroid precursors, and impaired erythroid maturation. This results in a low production of red blood cells and anemia, which is common in certain hematologic disorders. A major factor that has been shown to contribute to ineffective erythropoiesis is increased activity of TGF-beta superfamily ligands. Let's take a closer look at one of the causes of ineffective erythropoiesis. TGF-beta superfamily ligand overactivity has been proposed to contribute to ineffective erythropoiesis through inhibition of erythroid maturation. TGF-beta superfamily ligands exert their effect on erythropoiesis through signaling involved in the SMAD pathway, in particular SMAD2/3. Signaling through SMAD2/3 has been shown to demonstrate an inhibitory effect on the maturation of erythroid precursors. During maturation, TGF-beta superfamily ligands bind to and activate specific receptors, including activin receptor type 2B, and elevate phosphorylation of SMAD2/3. This causes inhibition of erythroid maturation. Elevated SMAD2/3 signaling causes a stop in maturation of erythroid precursors, leading to a reduced number of red blood cells. Luspatercept promotes erythroid maturation through differentiation of late-stage erythroid precursors, also called normoblasts, as shown in animal models. Luspatercept is a recombinant fusion protein composed of a modified extracellular domain of activin receptor type 2B that is linked to the Fc domain of human immunoglobulin G1. Luspatercept acts as a ligand trap, binding several endogenous TGF-beta superfamily ligands. Luspatercept competes with activin receptor type 2B for binding with the TGF-beta superfamily ligands, thereby decreasing abnormally elevated SMAD2/3 signaling. Luspatercept helps regulate erythroid maturation during late-stage erythropoiesis by diminishing SMAD2/3 signaling. By decreasing the inhibitory effect of endogenous TGF-beta superfamily ligands on late-stage erythroblasts, luspatercept restores erythropoiesis by increasing the number and improving the quality of mature red blood cells based on preclinical studies. In preclinical models, Luspatercept improved hematology parameters associated with ineffective erythropoiesis. These include increased hemoglobin levels, improved red blood cell morphology, and improved red blood cell lifespan. For additional information about the role of luspatercept, an erythroid maturation agent, visit reblozylpro.com.